one error. Okay, so now we are going to all of us be using his model, and maybe Carl in 2 weeks he finds a better model than him. Okay, so Carl's models become the current forecaster case number 1, that is a machine learning model for a specific time frame, maybe 1 hour, for a specific market, Bitcoin, dollar. Okay, so in whatever data source that was needed for that, and whatever combination. So it's essentially, it should be a system that is improving over time, because at any moment in time somebody else can find even a better model, so the whole crowd start using the best model at each moment in time. Make sense?
I have a question here. Are all of these models objective to return of the investment, or for example, can we design models for reducing the volatility of the portfolio?
We are in a very early stage, and the question we are trying to answer is, can we forecast the next candle? No, we are not trying to answer, can we forecast the volatility or forecast the return? In this particular situation, we are trying to see if it is possible to forecast the next candle in a certain market with a small enough percentage of error that is useful. Because if you're going to give me a forecast that has 20% percentage error, then probably it's not useful, because 20% is too much to be useful. So is it possible to forecast other things? Yes, most likely yes. But then you will have to make some adaptation to what the machine learning model is trained for, and then maybe you can forecast volatility. Or maybe an interesting question would be, from all the top 100 cryptocurrencies by market cap, which is the one that tomorrow is going to be gaining more value? Let's try to forecast that. Anybody who can forecast that will get a lot of money. If you can have a crystal ball that tells you not how much, but at least which one from the 100 coins, which one is the one who is going to pump tomorrow. If you can know that in a consistent basis, you can profit big time. Okay, so for each question that you want to answer, you will need a different machine learning script that is training a model to solve that specific question. Okay? Today, as we are starting with this, we started with the forecast of one of the next candle. But in the future, the whole infrastructure can be reused for asking other questions. Okay? So that's the idea. Okay? Once people are using this and the crowd is big enough, and somebody say, okay, now let's try to forecast which is the coin that is going to pump tomorrow. Well, another machine learning script somebody will have to build, and then we, instead of putting only here 1 hour, 4 hour, or the epochs, we put which script do we want to run. Forecast one candle, or forecast which coin is going to pump. Okay? So we want to test this, and we test.
Do you forecast for every hyperparameter or just the best one?
It depends on who is running the test server. If you want, you can go and run a test server that only you forecast the epochs. If you want to, and you fix some of all of the other parameters, because you know that works better. Okay, so it depends who is running the test server. The one who's running the test server is the one who is defining what is going to be tested. Okay? If you already know that 500 epochs doesn't make sense at all, then probably your test server is going to run only this. Okay? So it's a configuration.
So can I ask something? So like, if I understand it correctly, I set up a test server, and I have a script for it. And I want other people to test it also, and we decide collectively which one is the best. That's the use case, right?
Yes, that's the generic use case.
Yeah. So that script I created can be anything. Is it?
Yeah.
So okay, that also covers that volatility reduction example.
if your focus is on volatility and you want to predict the volatility, you reuse the whole infrastructure. You will probably have to write or modify the current Python script that is feeding the information in a certain way to the machine learning training process. You change it for whatever you want, and then your model is going to predict something else. Okay? But most likely you will reuse most of the infrastructure.
This is the best feature, I think, for this product.
Sorry?
I think this is the best feature for this product, in my opinion. Because it allows you to execute one script with other people, also those people have benefits over those scripts as well.
Yeah, well, that's the idea. That's the idea. Still is in a very early stage. People, one of the first challenges we had is when you put too many possibilities on a test server of things to try, then the amount of combinations is too high. And then even with a crowd of people, you cannot do it. It would take years. So you need to partition the whole space of combination into things that you think that make sense. And then in practice, what people are doing, instead of trying all the combination of all possible indicators, they say, okay, today we are going to try the combination of this and the epochs and whatever parameters, but only, I don't know, with Fibonacci type of indicators. Okay? So that is, I don't know, maybe 1,000 combination of stuff, and they run it against the crowd, and in a week they test everything related to Fibonacci. Then next week, the manager of the test server that is running said, we are going to try this now with whatever other type of indicator. And the idea is that somebody should be analyzing the results, what worked best. It was in 1 hour, in 2 hours, in 8 hours. Maybe, each indicator has many properties that you can use. Bollinger Band have a moving average, but also the band, upper band, the lower band, and percentage bandwidth. So maybe there are some of the things that are redundant, and maybe you don't need to put both lower band and upper band, because in the end it doesn't have an impact on the performance of the model. Okay, so that's the job that kind of the test server manager has to analyze and to figure out by trying and putting the crowd to work, and try to reduce the test space, because the test space are millions and millions of combinations. Okay, so that was one of the first things that we saw. So the answer to the question, is it possible to forecast the next candle? We still don't know it, because people are trying indicator by indicator each week, advancing a little bit more, and also the system is being debugged and being optimized a little bit. It's a new part of the system. But another aspect of this is, how do we incentivize people to do it? The first obvious incentive is to receive the forecast. Okay? Eventually, the forecast is good enough. That should be quite an incentive, because imagine you have the power to know which is going to be the next candle with 1% error. It's quite powerful, right? So, but in the meantime, while the crowd gets to that point, it needs an incentive to bootstrap all the stuff. So what we did is that we added to the governance system of the project, that we didn't explain the governance system. Maybe that's something Julian should talk about, the governance system of one of these sessions. We make an upgrade to the governance system so that we can incentivize by tokens the people who are running test servers and the people that are finding the best models. Okay? So from a governance system that incentivizes people for contributing code or icons or art or documentation or data mines or everything that we were incentivizing before, we added a small another piece to the governance system so that we can incentivize people who are running these guys, who are running these forecasters, and who are discovering better models. Okay? So from several months now, there is a group of people that is going in this direction, and they are running this software together with a network node we call network this is the node of our peer-to-peer network. That is still in a very early phase of development. There are 1 or 2 nodes running, but in fact, what's actually happening is that this test server is connecting to the network node, test client is connecting to the network node, and this guy is connected here. The network node is the software that recreates a peer-to-peer network, and specifically it has different services. One of the services is the Bitcoin factory project. So they are connecting through the Bitcoin net node, specifically this service, and they are talking to each other in a way that allows anybody to run this software from their own computers. Okay, so you can run it, the test server in a Raspberry Pi. Okay, and you're going to be connecting to the test clients that are also being run by Carl in Sweden in his Raspberry Pi. Okay, but they are not going to talk directly. There is a guy in the middle that is on the open internet, that is a network node that everybody can see. So this guy talks to this and send a message to this, send the model, the data, receive the data, produce the model, and returns the results, and keep tracks of all the results, and the forecaster do the same. So that's where we are today. There was a parallel road. One guy was saying, okay, that's good, but I don't want to forecast the next scandal. I don't really believe that is possible. But what I want to do is to run to train a machine learning model with on the side of reinforcement learning. Okay? Reinforcement learning is a different type of machine learning model where you have where you can model an agent with a certain trading strategy. Okay, and the agent then the model allows you to predict when is the right time for you to buy or to sell. Okay, so the engine during the training process in reinforcement learning is going to run the strategy in all possible different scenarios or all possible different decision paths, let's say. So it's going to try all possible combinations, to put it in simple words, okay? And when it is trained, then you can ask the model, look, I have this current market data, okay? What would you do now? Would you buy, would you sell? What would you do, okay? The model is already trained to perform the best possible, okay? So there is a guy that is going in that direction, and he replaced the script that is run here. The server is running inside a Docker container. Inside a Docker container. It's running a Python script for creating a machine learning model to predict the next scandal. The guy created, this is script number 1. He created a reinforcement learning Python script that in this case is training a model to trade. Okay? Specifically to try all the combinations so that it can trade profitable. Okay? At least with a train for that. So the guy, by creating this, is more or less what I was telling you can do. He created a different type of machine learning model, but he's reusing all this infrastructure. Usually these guys are even more intensive to train than these guys. These are between 15 minutes or 1 hour, let's say, but these, every time you have to try one combination of parameters, and this reinforcement learning is taking maybe 1 or 2 days. Okay, so once the guy finished this, then the people who want to participate in his test, they can freely choose him as the provider of the test cases, and their machine, instead of being running 1 hour for every test case, they will run between 24 or 2 or 3 days. But each one is going to test different kinds of parameters, and somehow they will find which is the best model for this, specifically for this. And then he expects with that to produce signals with the best possible model. Okay? And he will move it forward in that direction. I've seen another guy that is also joining him and is trying to push this forward to finish it in a not in long term, maybe in months or two. Questions so far? No? Machine learning questions? Well, this is kind of an overview of one aspect of the system that is quite new.
Can I ask something?
Sorry?
I have a question. Let's say for that reinforcement learning guy, you need some specific libraries to train a reinforcement learning model. How you are making sure that test clients have those libraries and so on?
Because you put those libraries inside the Docker container
Okay.
that they installed previously for running this. Yeah. More question, guys? This is your opportunity because then I forget everything about this and nobody can answer any. Carl, any question, Carl? You know everything about this, right?
No, I haven't dug so deep into this actually on myself. It's just interesting.
Yeah. What is going on lately on this is that after I code the basic structure, some people are taking care of the individual pieces. That is something that we are looking forward also to divide the system in different people that can maintain certain parts. So, for example, there is one guy that is taking this and starting to maintain this. That is the one that wants to take over this and do this part. But there were people fixing bugs here and here also. Now it's a little bit more stable. There is a group of people. There is a Telegram group called
Machine Learning.
Machine Learning. Okay, where the people that are playing with this stuff, they are hanging out there, and they are running their servers, talking the server, and trying different stuff. Okay. So if you ask me, I'm not sure if the candle can be predicted accurately enough.